In Unit 2.4, the structure of the atom notes, I have divided it into two parts. In the first part that I will discuss in this lesson, we are going to talk about these 11 topics. The last one is problem discussion. The second video will talk about topics 12 and 14. So, number one, what is the atom? It is the smallest particle of matter that retains the properties, chemical and physical, of that element. So, if you look at this atom on your right, there are two regions in the atom, the nucleus, which is made out of protons and neutrons, and the electron cloud that has the electrons that move around rapidly, as we learnt in the previous lesson. So the nucleus has an overall positive charge and the electron cloud has an overall negative charge. The mass of the nucleus makes up 99.9% of the atom. So the mass of the atom is equal to the mass of total protons plus neutrons, or the nucleus. We discount the electron cloud mass because the electrons are so tiny. And this electron cloud is kind of a hollow region. It's basically empty space. Number two, what are the subatomic particles and what are their charges and relative masses and actual masses? So you need to remember the green highlighted sections in this table. So protons and neutrons are found in the nucleus and electrons are found in the electron cloud. Since they have such a tiny mass, this is a decimal number with 24 zeros before this number. So you can imagine it's tiny, and both protons and neutrons have a similar mass, though neutrons are slightly heavier because each neutron contains a proton and an electron. And the mass of an electron and a proton and a neutron it's very hard to write it in grams because of all the decimals. So we use relative mass units called AMU. We will explain it further in another slide. Proton has a mass of 1 AMU, we just call it 1. Neutron has the mass of 1, and electron is almost 2000 times smaller than the protons and the neutrons. Each one of the protons has a +1 and neutrons have a zero charge because it's made out of a minus and a +1 proton and an electron, and electrons, each of them has a -1 charge. So if I give you an atom drawing, how would you find the number of protons? It's equal to the number of electrons in a neutral atom. A neutral atom is an atom that has equal numbers of protons and electrons, resulting in a zero charge. What about neutrons? The number of neutrons is equal to because they have a number and the mass are both 1, a number, that's the mass of the atom, minus the number of electrons in a neutral atom. Also, the neutron number is equal to the mass number of the atom minus the number of protons, because the atomic mass is made out of protons plus neutrons. This will become more clearer when we do problems. Electrons are equal to the number of protons in a neutral atom. So now we're going to talk about ions. Ions are atoms with an unequal number of protons and electrons. Basically, they are not neutral atoms. That give them a net or total plus or minus electrical charge. And in other words, atoms are, if atoms lost or gained electrons, they are called ions. So there are two types of ions. The cations or plus ions are positive, like the cat's paw. They are positive because they have more plus charged protons because you lost electrons. Remember that. And anions sound like onions. They are negative. That's because they have more electrons than protons. That means they gained electrons. That's why you're more negative. So number 5, atomic mass units. One atomic mass unit is a very tiny value, as you can see here. So since the mass of an atom is so tiny, we measure the mass of all atoms relative to the mass of a carbon atom with a mass of 12. So this is called C12 isotope. One atomic mass unit is defined as 1/12 of the mass of a carbon-12 atom. Number 6, mass number. Mass number refers to the mass of an individual atom. It is equal to the number of protons plus the number of neutrons, as I showed in the table earlier. So if you look at the periodic table tile for a given atom, you have two values. They may be swapped in the top or the bottom. One is the atomic number and one is the average atomic mass of the element. So the mass number is not found in the periodic table. The mass number is a whole number, not a decimal number. Atomic number, shown over here, is a whole number because it shows the number of protons in the atom. And this number is unique to each element. So all carbon atoms have 6 protons. Elements are arranged in the periodic table based on increasing atomic number. So what is an element? Element is a type of atom that has the same number of protons in their nuclei. So all atoms belonging to one element have the same atomic number or number of protons. So let's look at isotopes. See, here's a picture of twins from an Asian country. They are identical twins. So isotopes are also like identical twins, triplets or quadruples and so on. So atoms that have the same number of protons but have different numbers of neutrons resulting in different masses are called isotopes. So all elements have isotopes. If atoms are isotopes of each other, then they are obviously the same element. And isotopes have very similar chemical and physical properties. So how do you write isotopes when you write chemistry? So say you have a magnesium atom with 12 protons and an atomic mass of 24 AMU. You can write that in two ways. One is the hyphen notation shown over here. You can write the symbol of the element, hyphen, and the mass of the atom. Or you can write the symbol of the element and you write on the left side as a subscript, you write the atomic number. That's the number of protons, and the heavier mass you write on the top like this, the mass number. So always the mass number is here. The nuclear notation gives more information. So here you can also write the full name of the element with a hyphen for the hyphen notation. This table shows you the two ways of writing the isotopes of carbon, 3 different isotopes of carbon, 12, 13, and 14. Number 10, the atomic mass of an element is also called the average atomic mass. We're going to learn how to calculate this in the next video. but for now you need to know it's the sum of the masses multiplied by the percent abundance of all isotopes in a naturally occurring sample of the element. Or simply put, it's the weighted average of all the isotopes in the element sample. Again, atomic mass of average atomic mass of the element is the one that's found on the periodic table, and this value is close to the mass of the most abundant isotope because this is the weighted average. So let's do some questions based on calculating the number of calculations based on protons, neutrons, and electrons. So first question, what is the mass of an atom with 3 protons and 3 neutrons and 3 electrons? So the mass of an atom is based on the protons and neutrons because electrons are so light. So you add the P and the N, and the answer is 7 AMU. Question 2 is based on this figure. I might give you a figure like this, or I might give you a figure like that. And you are supposed to find the number of total protons. So you count the red particles, and it's going to be 6 protons. And the number of total neutrons, you count the blue, it's also 6. And then the number of electrons, you count the black dots, it's 7. So you're going to answer these like that. And the net charge of the nucleus is based on how many protons you have, because neutrons have no charge. So it's going to be plus 6 because we have 6 protons. The number of total electrons, we already found it. So what is the net charge of the electron cloud? It's the number of electrons, and you put a minus sign in the front. What about the net charge of the atom? It's the difference between the protons and the total electron charges. So that would be 6 minus 7 or minus 7 plus 6, either one. You get a minus 1 charge because you have 1 extra electron than you have protons. Is this atom an ion or an atom? The answer is based on the net charge. So it is an ion. It's an anion. What is the mass of the nucleus? So you add the protons and the neutrons. It's 12. What is the mass number? Again, it's the same as 12. Atomic number is the number of protons, so that's 6. Element name is based on the number of protons. In this case, it's carbon. So you're going to look at the periodic table to see who has the atomic number of 6. Let's try a new question. Fill in the blanks based on the information given here and found on the periodic table. So you are given in first atom, you're given protons, none of the protons, neutrons or electrons, but you are told it is neutral and it's fluorine. So you're going to look in the periodic table and find where fluorine element is. It's right there, and it has 9 protons. Atomic number is 9. So you're going to put 9 there and 9 for electrons. And you can find the number of neutrons roughly because it's a whole number. The average atomic mass of this element is 18.99, which means 19. So you're going to subtract 9 from 19, the number of protons, and you get 10. Question 2, you are given neutrons and electrons. You are supposed to find the protons and the element name. So it's a neutral atom, so the protons and electrons will be same. And then now that you have 12 protons, you can find who that is. It is magnesium. So you put Mg down there. The third atom, you are given neutrons, only protons. You are supposed to find neutrons and electrons. You are given the mass of that atom as 28. It's supposed to be a cation with a 3+ charge. So you can find who it is because you are given the proton number. Anyway, so you're going to say, find the neutrons. It's going to be 28 minus 13, which is 15. And since you have a 3+ charge, that means you have don't have equal numbers of protons and electrons. You actually have more protons, meaning you lost electrons. So you're going to subtract 3 from the number of protons. That will give you 10 electrons. So if you add up the total charge of the atom, nucleus is 13 here and electron cloud is minus 10. If you add them up, you get +3. So your answer is correct. And who is this element? It is none other than aluminum. So the fourth one, you are given protons. You are supposed to find neutrons and electrons with the information of the atomic mass and that it's a neutral atom. So you have the mass of this atom. You can subtract 36 from 84 and you're going to get 48. That's the number of neutrons. And since it's a neutral atom, it will have 36 electrons as well. And who has 36 electrons? That is the noble gas krypton. So you're going to put Kr. Let's go to another problem. Now these are questions based on isotopes that we learned before. Question 1. I have given you 4 atoms. You see their protons, electrons and neutrons. I'm asking which ones are isotopes. So you should think, what information do we need? Isotopes are like identical twins with the same number of protons. So count the protons. Whoever have the same number of protons is the answer. And it is B and D. Here is nuclear notation of 4 different atoms. It's asking which of these atoms are isotopes. So the bottom number, you must recall, is talking about the number of protons or atomic number. Top number is talking about the atomic mass. This top number is made of protons and neutrons. So you just have to see who has the same number of protons. So it's going to be S and M. So another question based on isotopes. This one has 4 atoms and it's asking which of the above atoms are isotopes and explain why. So you're going to count the red protons and see who has the same number of protons. Pause and figure out how to answer this question. And then I've asked which elements are these. So part A is 2 and 4. They both have 5 protons. And what elements are these? Because you're going to find who they are. 1 is lithium because it has 3 protons. 2 and 4 are boron because they have 4 protons. Sorry, boron because they have 5 protons. 1, 2, 3, 4, 5. 3, 4, 5. And number 3 is 1, 2, 3, 4. That is going to be beryllium. So to quickly review, we discussed how the atom is defined into the nucleus and electron cloud and their charges. Nucleus is positively charged, electron cloud is negatively charged. There are 3 subatomic particles, protons, neutrons and electrons. Protons have a plus charge and electrons have a negative charge, and neutrons have no charge. Neutral atoms have equal numbers of protons and neutrons and giving them a 0 charge. Ion is an atom that either lost or gained electrons. If you gain electrons, you have a minus charge. If you lost electrons, you have a plus charge. Atomic mass unit is how we measure the mass of atoms, because atoms are so small. And 1 atomic mass unit is the mass of 1/12 of a carbon atom. Mass number of an atom is the mass of an individual atom. It's not found in the periodic table. Atomic number of an atom is the number of protons in an atom. All atoms belonging to an element has the same atomic number, and periodic table is arranged by the increasing atomic number of elements. Number 8 elements are atoms with the same number of protons. Isotopes belong to the same element. Isotopes are atoms with the same number of protons, but different numbers of neutrons, resulting in different atomic masses. Atomic mass of an element is the weighted average of all the isotopes of that element, and we discussed how to solve problems. And here is a look at what you read in a periodic table tile. The atomic number and the average atomic mass roughly equals total protons and total neutrons of the most abundant isotope, and there is an element symbol. These two numbers may be swapped depending on the periodic table, and that's it. I'll see you in the next video.